All right, now it's recording. I can't believe I forgot to record. So now it is recording. So say that one more time, Sailor. What'd you say again? Oh, with the lowercase. Yeah. My memory's not so good, so you only said it like 5 seconds ago and I forgot already. But you're right. You can name this with a lowercase letter as well. But let's do the uppercase. Let's do the capital letter. So if I wanted to name this, I could call it line AB. It doesn't have to go in order from like alphabetical order or from left to right. It doesn't make any difference what order you put those points in. So I could call it line AB. Now here's how we do it. We'll put the A and the B next to each other. We'll put a little line with arrows on the end. Okay, so that's line AB. Or what's another way we could call this with the points? What's another way you could call this? It doesn't matter what order. So, well, there's no C on here. BA, right. So we could call it line BA. All right. Now, if you just put BA and no line over top of it, that means something a little bit different than line BA. So when you're referring to line BA or line AB, that's how you're going to write it, just like this, okay? But we would say, like out of our mouth, we would say line AB. That's what that little symbol means. Make sense? Yeah, pretty easy. Now, what if, let's stick another point in here. We'll call it C. Could we still call this line AB? Yeah, absolutely, okay? You only use 2. Even though there's 3, I could put 4, 5, 6, 100, 1,000, 1,000,000 points on here, okay? I don't know how I'd name 1,000 points or 1,000,000 points, but I could put as many points as I want in there, and I'm still only going to use 2 of those points. And it doesn't matter what 2 points you use, and it doesn't matter what order you put those 2 points in, all right? So you got a lot of options. Well, I could still call this line AB or line BA, but now I got some other things I could call it. Just throw some things out. What do you think? Line AC, I could call it. Then line CB. Then I could go backwards, couldn't I? I could call it line CA. I could call it line BC. Is that all the options? I think that's it, right? AB, BA, AC, CA, CB, and BC. Yeah, those are all the options. But those are all valid options, all right? So if they ask you on a homework problem to name this line and they have 3 points, you have, I think that's 6 choices, right? You have 1 out of 6 choices to pick. You don't have to do all 6. You could just pick one of them, and that'd be fine. And here's one more way. Seems like I am teaching that whole lesson now, doesn't it? So I'm just going to review, but that's okay. All right? You could name this with a lowercase letter, all right? So if I put a little a right there, that does not represent a point. Remember, a point is always a capital letter. So I could just call this line A. So I don't need 2 points. I could just call it line A. I think maybe I used an M or something like that, or line L. Okay, it doesn't matter. Whatever letter of the alphabet, as long as it's lowercase, we could just call it that. Sometimes, you're going to see today, sometimes it's a little bit easier just to name it line L or line M or line B or C or whatever than using all the points, okay? Sometimes it's better to use the points. It all depends on the situation, so I want to show you both of those. All right, let's do a plane. So let me draw this, and then I want to slant it a little bit. If I remember where to go, I think it's transform. Yeah, and I'll do this. I don't know, slant it, let's say, 30 degrees. How's that? Whoops. So this is basically what we view as a plane. A plane is just a flat surface, basically. If you just think of it as a flat surface, but it's made up of a bunch of lines, so a line keeps on going forever and ever. So what do you think a plane does? Plane keeps on going forever and ever, doesn't it? All right. We can represent planes by things we see in here, like the ceiling. Like that ceiling could represent a plane. This wall could represent a plane. You could have like the top of this book right there represents a plane. But this book has edges, right? That ceiling has edges. It's got an ending. But does a plane have any ends? No, it keeps on going forever and ever, okay? So I think I might have talked about that, did I, in the video? All right, so let's just talk about how to name a plane, all right? There's 3 ways, or 3 ways. There's 2 ways, basically, to name a plane. One, let's start with the lowercase one. We could put any letter that we want. Let's use a K this time. That's a lowercase k. In any corner, doesn't matter. I put it in the top left. It could be on the top right, bottom left. It doesn't make any difference. So we would call that plane. So if we were going to speak it, we would say plane K. And there's no symbol for plane, okay? You actually write the word plane in front of it. Like, and if you use a lowercase letter, you have to write the word line in front of it. But if you have points on a line, if you want to name that line, you don't have to write the word line. You've got the symbol already there, okay? So again, this is really not real math stuff. It's just vocabulary. It's just learn how to write, learn how to read. Geometry is basically all this is right now, okay? And it might be that like that for a little bit. Because we're going to use this stuff, again, like I said, the rest of the year. Here's another way you can name this plane. Let's just copy and paste it and put it over here. Oops. There we go. You could put some points in here, right? So let's just call it A, B, and C. All right. So you need at least 3 points to be able to name a plane. All right. So a line, you need at least how many? 2. All right. On a plane, you need at least 3. So again, there's no symbol for plane. So we write the word plane, and then you just pick any of the 3 points that are in here. I could have 5, 6, 7, 8, 9, 10 points in that plane, but you don't pick all 10. You only pick how many? 3. All right. So we only have 3 in here, so there's not much to choose from. And it doesn't matter what order you put them in. All right. I'm just going to go alphabetical, but it doesn't matter. Okay. I could call this plane ABC. I could call it BAC, CAB. I could go backwards, call it the other ways. It doesn't make any difference. Okay. As long as you have 1A, 1B, and 1C, then you just call it plane ABC. Everybody good? All right. That's the first lesson. That's the stuff that was on the video. Let's do some actual definitions. Remember, those were undefined terms, right? They don't really technically have a definition. But now we are going to have some definitions. So you should be writing this down. You shouldn't be just sitting there with your arms folded, messing around, doing stuff. You should be writing this down. This is part of 1, 2, but it's part B. Yeah. All right, the first one, it's called collinear. Collinear points. All right. It is. It's points that lie on the same line. So write that down. Put it in your notes. You should have your notebook out. Points that lie on the same line. All right. It's pretty simple. Well, let's just do a little picture with that. So we need a line. There we go. Let's not do A, B, and C again. Let's be a little bold. Try some different letters. All right. So what can I say about these 3 points, X, Y, and Z? They're collinear. Why are they collinear? Because they do what? Because they lie on the same line. Okay, so they're all on the same line, so they're collinear. But what if I had a point like way out here? Call it A. Are all 4 of those points collinear? No, they're not. Okay. What about X, A, and Y? Are they collinear? No. Why? Because A doesn't what? Doesn't lie on that line, right, with the other points. Make sense? Yeah, pretty easy. All right, so collinear, because you see the word line in linear, don't you? Oops. It does that sometimes. See that word right there, line? And co means with, right? So it means they lie within the same line, all right? So that's where they get that word collinear. That's pretty easy. So I'm not going to write the definition, but what if I said that points were non-collinear? What does that mean? That's right. It just means they're not on the same line, all right? So if I asked you, here's the question. I would say points X, A, and Y, are they collinear or non-collinear? What would you say? Non-collinear. It's easy as that. All right, simple. What if I said points Y and Z? Actually, let's do 3 of them. X, Y, and Z. What would you say about X, Y, and Z? They are collinear. All right, so that's about as easy as that gets. All right, here's another word. Another but it's concurrent. And this time it's lines, it's not points. Concurrent lines. And they are lines that intersect at one single point. Lines that intersect in a single point. In a single point. There we go. Okay? Now, this time it's lines. We're not talking about points necessarily. We're talking about lines, and they intersect at a single point. So let's get a little colorful. I'm tired of just the black and white right here. So there's one line, and then there's another line right there. And we can say that they're concurrent lines. Why do I know that they're concurrent lines? Because what do? They intersect. Okay, they touch each other. That's what intersect means. Okay, they touch each other and they cross each other, if you want to say that, at one single point. Yes. Yeah, we should. Technically, we should. I was just a little lazy on that, but yeah, you're right. If they're lines, they should have arrows on there. You can add those if you like. All right. So they intersect at a single point. So if I call that point P, you could say where are these lines concurrent? Okay, where are they concurrent? Well, they're concurrent where they intersect each other. Okay, and so you would say they're concurrent at line P. So if I call that line L, and I call this, if I call this line M, all right, so you could say that line L and line M are concurrent at point P, or you could say that they intersect at point P. That means that line L and line M are concurrent lines, right? Just vocabulary, nothing big deal. All right. Yeah, let's keep going. What time's this class over? What is it? I don't know.
They're off a little from last year. Yeah, 9:40. There you go.
All right, so we've got like 12 minutes left. So let's continue. Let's go back to white for writing our definitions. Oh, I know what I want to do. Before we do the next stuff, let's do this. We got one like this. So everybody draw this.
Under the X.
What's that?
Under the X.
Just the next thing in your notes. So wherever you want to put it in your notes is fine with me. All right, so there's a cool looking picture. There's arrows on the ends of all these. If you want to put the arrows, you can. But yeah, technically in our head, we know that there's arrows at the end of all of these things right here. Okay, so let me put some letters in here. Now here's something. I did this the other day for my other class, and I should have told them. When you have two lines that intersect each other, if I just put a letter, really close to where they intersect, that basically means that that point of intersection is point R. Does that make sense? So you're not always going to see a point though. All right, if you just have a capital letter there, that automatically means right next to it where they intersect, that's the name of that point. All right, so I'm not even going to put a point there. Then I'll call this T, call this S, and we'll call this, I'll tell you, and then let's put a point on this line right here and call that V. All right, and then let's pick a different color. Let's pick this color. So we'll call this up and down line right here, this vertical line, we'll call that line K. We'll call this one line L, that slanted one. This one down here we'll call M. And then this one we'll call N. It's supposed to be an N. It's kind of weird looking, but that's what it is. It's a lowercase n. All right? So here's the question. This is the kind of stuff they're going to ask you. Let's put this in white. Okay. Oops, I thought it was in white. Let's try it again. There we go. All right.
What's the that thing?
It's an N. Yeah. LMN. It's kind of weird looking, but that's what it is. All right. The first question is name 3 collinear points. So that's question 1. They give you this picture, and they ask you to name 3 collinear points. So take a look at it. Give me 3 collinear points. What do you think? S, V, and T, right. S, V, and T. It doesn't matter what order you put them in. They are points. They're separate points. So I'm going to put S, comma, V, comma, T. All right? So that's how you would write that answer. It doesn't matter what order you put in. It doesn't make any difference as long as you list those 3 points because they all lie in that same line. Correct?
Wait, so for us to do a collinear line, I have to
Collinear points. Yeah. On the same line. They got to be on the same line. So could I consider like T, R, and V on the same line? No. T, R, and V are not collinear, are they? All right. Now, if I pick 2 points, could I say that R and V are collinear? It's kind of a trick question a little bit. If I just pick 2 points, any 2 points you could put a line through, couldn't you? All right. So I could take any 2 points. Could I take any 3 points and always put a line through them? No. Because look, I got T, R, and V. There's no way I could put just one line that goes through T, R, and V. But could I put one line that goes through R and V? Absolutely. It's not shown, right? But I could put a line through R and V. So could I consider R and V to be collinear? Yeah, any 2 points could be considered collinear. So really, what I need to look at, are 3 or more of those points on the same line, okay? If 3 or more on the same line, then we could say it's collinear. Make sense? Right? So that's it for number 1. Question number 2 says, name 3 non-collinear points. If you want to write down the question, you can. I just didn't do it. So number 2 says, name 3 non-collinear points.
R, K,
Well, is K a point?
no.
3 points that don't lie on the same line. That's what you're looking for. That's what non-collinear means. Simone, any guesses? 3 points that don't lie on the same line. We actually talked about it just a minute ago. Yeah, R, V, and T. Right, those are the ones we talked about. R, V, and T, they don't lie on the same line, do they? Are there any other points that don't lie on the same line? 3. 3 points. R, S, and T. Good. Give me something else. R, S, and V. Right. They don't lie on the same. There are 3 points, but they don't all lie on the same line. Make sense? So I have an option of using any of those. All right. So a lot of times that'll happen. You know how in algebra you usually just have like one answer and that's it. There's no other answer. In geometry, every once in a while, there's going to be multiple answers that would work. All right. And so what did we say? What was the first one? R, V, and T. So let's just write that down. But you could have said R, S, and V. You could have said, what was the other one we said? R, S, T. Yeah, we could have said R, S, T. All right, and they would have been fine answers as well. I believe this book does it, like the odd answers are in the back of the book, and I have no problem with you looking in the back of the book. In fact, I encourage you to do that, but not, look at the problem, flip to the back, then write the answer down. I mean, you try to figure the answer out, and then you can look in the back to see if you got it right. Okay, that's why they're back there, right? Just to make sure when you get home and you don't have a teacher sitting right next to you that you know if you're doing these problems right or not. So I encourage you to look in the back of the book. Some teachers, I've heard of teachers that like black out or rip out the pages in the back of the book with the answers because they don't want the kids knowing the answers. Nah, the author of the book know what they're doing. They put them back there so when you do your homework, then you know at least if you're doing it right or not. Okay? All right. Number 3 says name 3 concurrent lines. 3 concurrent lines. Look back at your definition for concurrent. All right? So you want to have 3 lines that are concurrent. What does it mean to be concurrent? The lines do what? They all intersect each other. So give me 3 lines. Now, we're going to use the pink letters, okay? We're going to use the single letters because in this situation, we're naming lines. It's a lot easier just using one letter. Wouldn't you agree? And also, there's a line in there that only has 1 point on it anyway, right? And so you can't use 2 points. Okay, Ryan, what do you say? K, L, and N, correct. So K is this up and down one right here. L is this slanted one, and N is this one on the bottom. Why are they concurrent? Because they all intersect right there at that 1 point. I had somebody in my other class say K, L, and M. Are they concurrent? Because they were saying, well, they intersect here, but do all three of them intersect there? No. Okay? So where do all three, or name 3 lines that are concurrent? Now, you could say L and M are concurrent, couldn't you? Because L and M do intersect here. But the question says, give me 3. Give me 3 lines that are concurrent. Those are the only 3, right? This one, which is K, this one, which is L, and this one, which is N. So I'm going to put K, L, and N. Actually, technically, I would give it to you. If it was on a quiz or a test, if you just put K, I'd give it to you. But technically, you're supposed to say what? Line K, and then line, what is it, L, and then line N. All right? So technically, that's what you should write down. I would give it to you if you just put K, L, and N. I know exactly what you're talking about, so that's all I'm trying to do there. Does that make sense? Yeah, pretty easy stuff, isn't it? Haven't even done any math. Haven't added one thing together yet, have we? Haven't done anything like that. Eventually, we will. We will be doing some regular math eventually, but we got to learn this basic stuff first. We got to learn, what do they say, how to crawl before you walk or something like that, right? So that's what we're doing. We're crawling right now. Eventually, we'll be walking, and eventually, we'll be taking off and sprinting and running, okay? But right now, we're just crawling, just trying to get some basic ideas. Well, I had hoped to finish the whole thing, but we had to hand out the books and talk and all that kind of stuff at the beginning. So we'll just finish this up. We just have a little bit more to do, just some more definitions, and then I'll give you a homework. What's today, Friday? Yeah, so I'll give you your first weekend off, so no homework. I'm not, by the way, I'm not against giving homework on the weekends, all right? So, you know, it's not always going to happen, but we're just not quite finished the lesson yet. So we'll wait till Monday, and I'll give you homework on Monday. Start off a new week good with a nice little homework assignment, right? Okay, that's enough.